Hi, my name is David Cox and I'm giving this presentation on how to write a Xojo application for everywhere. So the first issue you may ask is, well, where is everywhere? What I'm meaning by that is write an application not only for the desktop, that is Mac, Windows, Linux, Raspberry Pi, but also write the same application for web, again, Mac, Windows, Linux, Raspberry Pi, for console, Mac, Windows, Linux and Pi, and finally for mobile, which at the moment is iOS and will soon be, or later will be, for Android. So the question we may ask is, well, why bother? Well, the reason is that the app idea and the app intelligence that goes behind it, that's the hardest part of the development. But once that's done, the user interface is much easier than it used to be. That also customers may demand a mobile version of your app. And if you, for example, create a web app, that tends to be more future-proof, unlike the desktop with things like Catalina. A web app may tide you over with your users, your customers, until Android arrives. Then another benefit is that it helps you find more bugs when you test it in other environments. And for those who are selling their apps, you may make more sales. So, there are two big issues that I've found when developing a cross-environment application. First of all is how to share the data. And the second one is how to share your application's intelligence across multiple environments. So, firstly, let's look at sharing your data. So, you've begun to write your new application. Where do you store your data that your application uses? Typically, there are two types of data. One is a local preferences file to store things like the last user login or any positioning of the windows or any locally cached data, and usually that's a SQLite database. The second type of database is where you store your main tables for the application. Everything is stored typically, as you see here, on one computer, single user access only. So the question is, who can now use your application? Who's going to buy it from the App Store? Well, only single users, or maybe at best multiple users who share the one PC one at a time. So the question is, how do we get around this limitation? Well, we need somehow to share the main database. So what we want is quite simple. One SQLite database, for example, accessible by an unlimited number of different PCs, all at the same time. Across the LAN, across the WAN, across the internet. Simple, in theory. Sure, we may need to designate one of the PCs as the master. The master PC, that is the one with the main database, and all of the other PCs running your application are clients of that one master. So you can see on the screen here, I've got a window showing how it might appear, where you can turn sharing off or turn sharing on, acting as the server, or turn sharing on, acting as the client. So the question is, how do we do this? How do we manage it? There seem to be a few possible alternatives. One is that we copy the database around, that we make a SQLite database and we send it around from one computer to another. The trouble is we're now out of sync. We can try and sync it, but that's really quite difficult. Second alternative that you might think of is to share your database as your SQLite on a network drive. The trouble is that that's not supported and causes corruption problems. Third thing we may want to do is set up a multi-user database. The obvious examples being things like MySQL, Postgres, KubeSQL, etc. But this is often overkill for the small work group. All they want to do is talk to each other's computers. So the fourth alternative is peer-to-peer sharing. That's what I'm suggesting. But the question is, how? How do we do this peer-to-peer sharing over HTTP? Okay, so what does it look like? None of the PC clients can talk to the database directly, the main database. Instead, they talk to the master PC. The master PC talks to the database on behalf of the client, and that master gets the results from the database, then sends those results back to the client. Someone can even be working on the master at the same time that it's serving the other users. Now, if this works, let's just check to see if it would meet every configuration that we might need to be able to fulfill the requirement to be able to run everywhere. So we start off with one PC and one SQLite database. Peer-to-peer is turned off. Next, we turn peer-to-peer on. The original PC becomes the master, and all the other PCs become the clients into that master. But we now have a problem. We have a problem with firewalls, with other people needing remote access, with laptops, with iPhones, with home users. We have all sorts of problems in getting access to the data. So what we need to do then is move the master PC onto the internet to be an internet-based server, such as Amazon EC2. Then, if the demand becomes really excessive, we can move the peer-to-peer technology onto multiple REST computers, whether that's as web apps or as console apps in the cloud. And what we can then do is even change the database behind the scenes to something that is even more robust. So moving from the single user all the way up to a REST application, I think, should cover us in terms of putting our application everywhere. Now, what Xojo technology does this peer-to-peer database need to be able to work? Well, it needs, let me just go back. So it needs, because we can't access the database directly, we need to build a dictionary of the SQLite commands that we're going to be sending. We put them into as components, and then those components, that dictionary of SQLite components, we're going to be sending to the master PC. So the way that we do this is with a dictionary, and any blob fields, we're going to create a base 64 of them, because just so that it's easier to deal with as text. We're then going to take that dictionary and turn it into a JSON. We're then going to zip compress that JSON text so that it's smaller. Doesn't matter how much we want to send up. Typically you'll get at least a 50% compression. The bigger the text, the better it is. We then are going to encrypt that. We're then going to take that encrypted and zipped JSON, turn that back into a base 64, and then add that into a URL connection and send it off to AlloExpress. The advantage of AlloExpress is that it can run in the background of any Xojo application. It'll run happily in the background of a desktop application or a web application or a console application, receive all of your HTTP calls, process them, send the results back again. Okay, so that's what we do in terms of going outward from the client's perspective. Now we see what's going to happen from the allo perspective. So the allo application receives this the URL connection. It then needs to do everything in reverse. It needs to decode the base64. It then needs to decrypt that base64 text. It then unzips. It then turns what is now unzipped back into a dictionary. We undo the JSON, turn it back into a dictionary of the SQL components. The components being things like whether it's a select command, an update, a delete, an insert command, what the particular fields might be, any order, any insert, any order by, any group by, any where commands at the end. It then goes off and creates a prepared statement of all of those components and runs an SQL select or SQL execute command and then gets the results back as a record set. Now, if we're doing an execute, we don't have a record set, but what we do is then even though we don't have a record set, we're going to build a dictionary of all of these results, whether there is an error, boolean, true or false, what the error code might be, what the error message might be, all the fields of the record set, we base 64 them because we don't know what they may be. Normally they'll just be plain text and integers, but if we base 64 them, if one of the fields was a blob field, it will be fine sending it back and not muck up the JSON. So we get this dictionary of all the results, we JSON it, we zip it, we encrypt it, we take the encryption, we base 64 that, shove it back into the URL connection as the return results and send it back to the client. So what happens back at the client is it's just been sitting there waiting for the results to come back from the URL connection using the send sync. It then undoes all the things that allo did. It decodes the base 64, it decrypts it, it unzips it, and then turns the JSON back into a record set and returns each of the components needed, where it returns the record set if necessary, the error true or false, the error code, the error message, returns all that back to the application. All as if the client had queried a local SQLite file. Now remember, all of this works the same for desktop applications, web applications, and console applications on Mac, Windows, and Linux. But you may then ask, well, what about iOS? Yes, it even works on iOS. It works on iOS not with a URL connection, but using the HTTPS socket. So, the other things that you may need, or will need in my case, was the encryption. So I use the MBS encryption kit for the zip compression, also for the AES encryption. Okay, now that we are able to share the data from everything, with whatever environment, desktop, web, or iOS, we're able to access a common set of data. What about the actual app intelligence within the application itself? Well, first a few caveats. What not to do. Don't write multiple independent programs which are entirely separate from each other. It's too slow to develop multiple applications. It's too hard to maintain. Don't duplicate code. Again, it slows changes. Any change you make, you've got to make in multiple locations. And it also means that it's more prone to error. Don't aim for the lowest common denominator of an application. Put all of the applications into something like the desktop, and then if you are viewing on a mobile or a web app, then you may need to leave a feature out, but at least it's there in the other environments. Also, don't make your code for one application only. You may have a cool application where you're sharing the code amongst desktop, web and mobile, but you may find later on that the same code that you created is suitable for multiple applications. So make it extensible so it's not just suitable for your one application, but potentially for other applications you may write in the future. So they're all the what nots to do. Now we need to look at how we're actually going to compete this. To do it, we need a new approach to the UI, to the user interface. The best way of doing that is to create first a desktop application and pretending that it was a web application. So what that means is have a minimum number of windows. So for example, you might want to have a login window plus one other. So for example here, you can see we've got everything on the one window. You may want to use a list box with all the choices on the left hand side. Now I choose a list box because it's very easy to put icons in there, and it's also hierarchical and it also scrolls. Now I found that toolbars that you may use, which is the other obvious choice, don't scroll. Now there was a problem with web-based list boxes not being hierarchical, but I was able to get around that by having a very small left-hand column where I have a triangle-looking icon, which I detect on the left-hand side. Okay. The other thing you have to use is containers. So this application, for example, all in one window, uses a page panel on the right hand side to the right of the list box with containers inside it. You need to make sure that all of the fields that you place on the screen have consistent field names. Consistent not only so that you can identify what they are, but consistent because later on when we create a web application, we're going to look at exactly those same field names and use them through your code. Finally, use menus as a last resort, an afterthought. Yes, you can still have them on your desktop, but really don't make your application rely on using menus because they're not available on the web, or at least not easily. Okay, one of the things you can do then is to externalize everything that makes sense. If you have methods in modules, make them external. If you have windows that you can use from one application to another, make them external. Same with dialogues, containers, classes. You can't always share everything. Sometimes it doesn't make sense to share everything, but if you can, that would be great, particularly classes and the methods. They're the main things we're going to share. Now what you can do then is, if you have particular buttons on your windows, if they just have a small, obvious, unchanging code within them, within a button, then fine, keep that inside the button itself, and that will be duplicated, especially if they're unchanging. But if there's any amount of code that is large, that is complex, that is changing regularly, then move it into either a class or an external module, because we're going to be sharing it with the other environments. Now, I have found that more modules and more classes are the better. So I create new separate modules for everything, for all different things, and so that makes it a lot easier for me to be able to look up and find the exact module I need with the particular code that I need. I used to have everything all in one external module, but once it turned into hundreds of methods within the module, it became so hard to find anything. So create lots and lots of modules and classes with their code within each of them. It will turn out better in the long run. Now, one of the things that you will find when you go across multiple environments is that you can no longer pass environmentally limited parameters. For example, I used to pass things like a text field or a list box off to a method to work on. You can't do that because a web app doesn't have a text field object. Instead, it has a web text field, a web list box, a web pop-up, things like that. So what you need to do instead is you pass these environmentally limited parameters as objects. And then you can test them in your method to see if they are correct and create a new object within your code based on that type. Another thing that you can do when you bring them across is assume if you're writing the application and you know what's coming across, you may well assume that you know the object type and point the duplicate local variables to their original location. So what we've got here is a particular function which is going to which is passed a button, but also makes use of other objects within it. So for example, if in this case, if we were past the button, we pass it as an object. This, and above we have the desktop code, below we have the web code. In the desktop code and the web code down below, we define exactly the same names of variables. And that way our code underneath this definition of what the objects are is exactly the same. When it gets down there for a web, it uses the web application button. If we were on a desktop, it'll use the desktop button. And so we're actually able to have one version of the code down below to work on. So you can see up above the different ways that we're able to do that. So we bring in the My Save button as an object, and the first line of the desktop is we dim a new variable called Save Button, for example, as a push button, because we know that it's a push button coming across, and we say equals push button brackets My Save Button. And so we're redefining a new variable based on what we know as the object coming through. If instead you wanted to point it through to a particular location, so you can see the data list box is defined as a list box pointing all the way back into my application into a particular window. That's a little more limiting because it means that this method can now only be used in this application because other applications may not have that WinData window available in it. But you get the idea, hopefully, that once you define these objects at the top of your code, you don't need to touch them again. All your code underneath is exactly the same whether you've got a desktop app or a web app or hopefully soon a mobile app. Now, constants can also be your friends. We can use constants in many different ways. For example, I use a constant, not a property, but a constant in the app area called application name. The advantage of that then, because it's a constant rather than a property, is I can now use them in #if commands. So if you did, for example, have multiple applications that were using the same method, you could go, okay, if the application name is the desktop version or the web version or the mobile version, you can point them to a particular location within your code. The advantage then is everything still runs properly, but it will be limited to just that one web application, to that one application. Now it is possible for you to expand this to include other applications as well. It's a bit more wordy, it's a bit less generic, but that is another way of doing it. So what it means here is that you can use constants so that methods are able to be shared amongst applications that are completely incompatible with one another, that point to resources that aren't available in the other applications. So my goal here is that the user will be able to run our one application either as a desktop application or a web application or console or mobile application, or all four, as either just a single user running on one computer, or as a small work group of computers, or across the internet, all accessing one data, whether it's a SQL-like database or something bigger, or connecting even thousands of users to a huge multi-user database. So, with Android coming along, I think that makes about 14 separate environments to build and sell your applications to. So we have Mac OS, Windows, Linux, Raspberry Pi, 4 of those multiplied by the 3 different environments, desktop, web and console applications. Plus we have, so that's 12, plus iOS, plus Android makes 14. Sharing your code, sharing your data across 14 separate environments, I think means that you can write a Xojo application to run everywhere. So, what do I want to have happen from now? Well, obviously API 2.0 is going to make life a lot easier with the little idiosyncrasies of the language removed. But I'd still like some more things too. It would be nice to be able to take an object, say a desktop button or something from the desktop, and copy and paste it into the web, or copy a button from the web and paste it into the desktop, and have all of its parameters remain, all the coding underneath it remain there as in the pasted version. Now we're nowhere near that level yet, but that would be nice to have. I'd also like eventually to be able to have a container, an external container that is usable by both a desktop and a web application. Bring it in, and all the buttons and objects and things on there are shareable in some universal fashion between the desktop and the web applications. And then a lot of the code which at the moment I have to have externally to those particular buttons could go back into the button itself. Finally, while all of this is relatively easy and possible between desktop and web apps, it's a lot harder for mobile. But it would be nice if we could take the same idea, the same buttons that we've got on the desktop and the web, put them into, copy and paste them into mobile apps. Also, if we had containers as well to share with a mobile app, that would be excellent as well. Okay, as I said, my name is David Cox. If you have any questions, then please check me out on the forum and ask me any questions. Okay, thank you very much. Goodbye.